Hello viewers, in today's lecture we are going to study the concept of second order derivatives. Viewers, in our earlier videos we have discussed the concept of logarithmic differentiation, parametric differentiation and so on. Now let us take what is meant by second order derivative. Let y is equal to fx be a real valued function defined in its domain, then we know that dy over dx is known as the first derivative. This is known as the first derivative, and if we differentiate dy over dx one more time, that is, if we find d by dx of dy over dx, then this can be written as d2y over dx2, and this is known as the second derivative. Therefore, we can say that if y is equal to fx be a function, then dy over dx is known as the first derivative, and d2y over dx2 is known as the second derivative. Now, if we differentiate this second derivative, then we get the third derivative, that is d3y over dx3. So this is called the third derivative, right? Higher order derivatives, right? The fourth derivative is denoted by d4y over dx4. So this is known as fourth derivative. So viewers, if we go on finding the derivatives, then the nth derivative is denoted by dny over dxn, right? So this is called the nth derivative. So the notation for first derivative is dy over dx. The notation for the second derivative is d2y over dx2. Similarly, the third derivative is denoted by d3y over dx3 and so on. So the derivatives can also be denoted as y prime is first derivative, y double prime is the second derivative. Now y triple prime is the third derivative, right? Similarly, we can write y1 as the first derivative, y2 is the second derivative, y3 is the third derivative, and so on. The other notations for denoting the derivatives is suppose f prime of x is the first derivative, f double prime of x is the second derivative, and f triple prime of x is the third derivative, right? So this is how we denote the higher order derivatives. So viewers, this is just the introduction of higher order derivatives. Let us solve some problems. Now viewers, let us take this problem. Find the second order derivatives of the functions. So the first function is x raised to 20. Now let us take y is equal to x raised to 20. Now dy over dx is the derivative of x raised to 20, which is 20 x raised to 20 times x raised to 19, because here we have applied the formula for x raised to n, the derivative of x raised to n, this is nx n minus 1. Now this is the first derivative. We can also denote it like this. Now we have to find the second derivative, which is d2y over dx2. So this is 20 is a constant, so the derivative of x raised to 19 is 19 times x raised to 18. Again we have used this formula, right? So this is 19 20 this is 38 380, right? So this is 380 times x raised to 18. So this is the required second order derivative of this function, right? Okay, now let us take another problem. Suppose we have to find the derivative of say x cos x. So the first derivative is dy over dx, and here we'll make use of the product rule, and the product rule is d by dx of u times v, that is first function derivative of second, then second derivative of first, right? So here we have x, the derivative of cos x, then we have cos x derivative of x, right? So here we can write dy over dx is minus x sin x, because the derivative of cos x is minus sin x. Then we have cos x, derivative of x is 1. Now this is the first derivative. Now the second derivative is d2y over dx2, and again we'll apply the product rule here. So we have minus outside here. Now this is u, this is v, so we'll apply x, derivative of sin x is cos x, then we have sin x, and derivative of x is 1, and the derivative of cos x is minus sin x, right? So here this is d2y over dx2, and we have minus x cos x, minus sin x, and minus sin x. So we write it minus x cos x minus sin x is minus 2 sin x, right? So this is the derivative of x cos x. Now let us take one more example. Suppose we have a function, say e raised to mx. Now we have to find its second derivative. So let us take it as y. So dy over dx is the derivative of, we know that the derivative of exponential function is the function itself. So we have e raised to mx, then we have to differentiate mx by chain rule. So we have m, because the derivative of x is 1. So we have m e raised to mx. Now again differentiating, we get here this is constant m, then e raised to mx. Again if we differentiate it, then we'll get m e raised to mx. So this is equal to m square e raised to mx, right? Now viewers, let us take this problem. We have to find the second order derivative of e raised to x sine 5x. So let us take it as y. Now dy over dx is this is the product of two functions, so we'll apply this formula. So e raised to x, derivative of sine 5x is 5 cos 5x, right? Then we have sine 5x, and then we have the derivative of e raised to x is e raised to x. Now we can write it as e raised to x times, and this is 5 cos 5x plus sine 5x, right? So this is the first order derivative, that is dy over dx. Now we have to find the second derivative. So what we will do, we'll again treat this as u and this as v, and we'll apply this formula. So we have e raised to x, derivative of this function is minus, because here we have cos 5x and the derivative of cos 5x is minus 5 sin 5x. So this is minus 25 sin 5x, and then we have plus 5 cos 5x, right? So this is u, this is this whole function is v. So first function, derivative of second, so the derivative of second is minus 25 sin 5x plus 5 cos 5x, plus now we have this second function 5 cos 5x plus sin 5x, and then derivative of e raised to x is e raised to x. Now we have to simplify this expression. So we have e raised to x. If we take e raised to x common, then we have minus 25 sin 5x plus 5 cos 5x. Then we have plus 5 cos 5x, and then we have sin 5x, right? Whereas this is e raised to x, and this term and this term are like terms, so we have minus 25 and here we have 1, so we can write minus 24 sin 5x, right? And these two are the like terms, so 5 and 5 10, so we have 10 cos 5x, right? So this is the second derivative of this function. Now let us take one more example. Suppose we have to find the second derivative of sine say log x, right? So what we will do, we'll take it as y, and now we'll find dy over dx. So the derivative of sine x, because suppose we take log x as x, so we have sine x, so the derivative of this function is cos of log x. Then we have to differentiate log x by chain rule, so we have the derivative of log x as 1 over x. Here we have used the formula for the derivative of sine x, which is cos x, and the derivative of log x, that is 1 over x. Okay, so this can be written as cos log x divided by x. So this is the first derivative, right? Now we have to again differentiate it to find the second order derivative. So what we will do, we will have d2y over dx2, and now we have the quotient of two functions, so we will apply the quotient rule. So here we have x, derivative of cos log x is minus sine log x, and then the derivative of log x is 1 over x. Then we have minus, and we have cos of log x, and derivative of x is 1, and divided by x square, right? So here's now we have, if we simplify it, then we can write then we have d2y over dx2 is equal to here x and x get cancelled, so we have minus of sine log x, and here we have minus cos log x, right? So divided by x square. So this is the second derivative of this function. So here we have used the formula that is d by dx of f over g. If we have a quotient of two functions, then we have g times derivative of f, then we have f derivative of g, and the square of the second function, right? Now suppose we have the function, say tan inverse x, and we have to find its second derivative. So let fx is equal to tan inverse x. We can also take y equal to tan inverse x. Now the first derivative, that is f prime of x, is the derivative of tan inverse x, which is 1 over 1 plus x square. This we have written by using the direct formula. So the derivative of tan inverse x is 1 over 1 plus x square. Now we have to find the second derivative. So it means we have to find d by dx of 1 over 1 plus x square. Now this can be written as d over dx of 1 plus x square raised to minus 1. Now see, here we'll assume this 1 plus x square as x, so we'll make use of the formula d by dx of x raised to n, that is nx n minus 1. So here we have minus of 1 plus x square and minus 2, and then we'll differentiate by chain rule 1 plus x square, that is 0, because the derivative of 1 is 0 and the derivative of x square is 2x, right? So if we simplify it, we have minus 2x divided by 1 plus x square raised to square, right? So the derivative of this function, the second derivative of this function is minus 2x over 1 plus x square whole square, right? Suppose here if we have to find the derivative, say f double prime of say 1, then what we will do, we'll first find f double prime of x as this function, then we have to find f double prime of 1, so we'll substitute x is equal to 1 in this expression. So this is minus 2 times 1, and here we have 1 plus 1 square whole square, and this is minus 2, and this is 1 plus 1 2, so 2 square is 4, so here this is minus 1 upon 2. So this is the value of f double prime of 1. Now viewers, let us take this important question. Here we have y equal to cos inverse x is the given function, and we have to find the second derivative in terms of y alone. So we have y is equal to cos inverse x, then we differentiate it. So the derivative of cos inverse x is minus 1 divided by square root of 1 minus x square. So this we have written by direct formula. So dy over dx is minus 1 over square root of 1 minus x square. Now this can be written as minus 1 over 1 minus x square raised to half, and now we can write it as 1 minus x square raised to minus half. Now viewers, let us once again differentiate both sides. So we have d2y over dx2, and we have minus, and here we have minus half, 1 minus x square minus 3 by 2, and then by chain rule we'll differentiate 1 minus x square, which is minus 2x, right? So if we simplify this function, so we have d2y over dx2, and this 2 and this 2 get cancelled, so minus minus and minus gives us minus, and we have 1 minus x square raised to minus 3 by 2 times x, right? Okay, now here's we can write this function as minus x divided by 1 minus x square, and here we have 3 by 2, right? Okay, now d2y over dx2 is equal to minus of x 1 minus x square raised to 3 by 2. So this is the second derivative of this function with respect to x. But in this question we have to express d2y over dx2 in terms of y alone. So here's what we will do. From here we have x is equal to cos y. And if we substitute x is equal to cos y in this expression, then we have minus cos y, and then we have 1 minus cos square y raised to 3 by 2, and this is minus cos y divided by 1 minus cos square y is sin square y, so we have sin square y raised to 3 by 2, so 2 and 2 get cancelled, so we have minus cos y divided by sine of cube y, right? Okay, now this can be written as minus cos y divided by sine y times 1 over sine square y. Now minus cos y over sine y is minus cot y, and 1 over sine square y is cosec square y. So the second derivative in terms of y alone is given by this function. Now viewers, suppose we have to find the second derivative of this function, x square log 2x. So let us take it as y. So first we will find dy over dx, and this is the product of two functions. So we have x square derivative of log 2x is 1 over 2x times the derivative of 2x, and the derivative of x is 1, so we have only 2. Always remember viewers, suppose we have to find the derivative of log x, this is 1 over x, and suppose we have to find the derivative of log ax, where a is some positive real number, then a positive constant, then d by dx of log ax is again 1 over x, right? Okay, so now we have here plus this is log 2x, and the derivative of x square is 2x, right? So 2 and 2 get cancelled. Here we have 1 x cancelled, so dy over dx is equal to x plus 2x log 2x, right? Now we have to find the second derivative, so again differentiating it. So the derivative of x is 1, and here we have 2, and then again we have the product of two functions. So we have first function, then derivative of log 2x, which is 1 over x, and plus log 2x, then derivative of x is 1, right? So if we simplify it, we get 1 plus x and x get cancelled, so we have 2, and we have 1 plus log 2x, right? So this is 1 plus 2 ones are 2, plus 2 log 2x, so this is 3 plus 2 log 2x, right? So here's the second derivative of x square log 2x is given by 3 plus 2 log 2x, right? Now here's let us find the second derivative of log x, right? Say y is equal to log of log x. Now dy over dx is equal to here log of log x. So let us take log x equal to say t. So we have the derivative of log t is 1 over t. So we have 1 over log x. Then the derivative of log x is 1 over x, right? So this is 1 over x log x. So this is the first derivative of log x. Now for the second derivative, let us differentiate this function dy over dx. So this is d by dx of 1 over x log x. Now we have d over dx. We can take x log x as x log x raised to minus 1, and now here we'll apply the chain rule and as well as the rule x raised to n, that is nx n minus 1. So for the time being, if we take x log x as x, so we have minus x log x raised to minus 1, that is minus 2, and then we have to differentiate x log x by chain rule, right? So here's this is equal to minus 1 over x log x square, and here we'll apply the product rule. So this is first function, derivative of log x is 1 over x, then we have log x, and derivative of x is 1. So this x and x get cancelled, so we have minus of 1 plus log x divided by x log x whole square. So here's this is the second derivative of log x. Now here's this question can also be done in by using the substitution method, and I am explaining it for you. We have y is equal to log of log x, right? And we have to find the second derivative. Now what we will do, let us put say t is equal to log x. So this function y becomes log of t, right? Now find dy over dx. So we'll find d over dx of log t. Then by chain rule we write d by dt of log t, and then we have dt over dx, right? So the derivative of log t with respect to t is 1 over t, and dt over dx can be calculated from here. So dt over dx is 1 over x. So here we have 1 over x, so we have 1 over tx, that is t is again log x, so we have x log x. So this is the first derivative of this expression and this expression are same, so we have dy over dx is equal to 1 over x log x. Now we have to find the second derivative, so we'll proceed like this for getting the second derivative, right? Now viewers, let us take this function y is equal to e raised to m sine inverse x, and we have to find the second derivative of y with respect to x. So let us find. So here again we can make use of the substitution method also. So let us solve it by substitution method. So let t is equal to, say, sine inverse of x, right? So y becomes e raised to mt. Now let us differentiate y with respect to x. So dy over dx is e raised to mt, because the derivative of e raised to mt is e raised to mt. Then we have to differentiate this mt with respect to x. So dy over dx can be written as m e raised to mt times dt over dx. We have taken m outside because m is a constant. Now dt over dx can be calculated from here. So dt over dx is 1 over square root of 1 minus x square. So dy over dx is equal to m e raised to mt. T is sine inverse of x, and divided by square root of 1 minus x square. So this is the first derivative. Now we have to find the second derivative. So for second derivative, what we will do, we'll take e raised to m sine inverse x. See, e raised to m sine inverse x is equal to y. So dy over dx can be written as m times y divided by square root of 1 minus x square. Clear? So for this we have substituted y. Now let us take this factor to this side. So we have a square root of 1 minus x square times dy over dx is equal to my. Now we have to find the second derivative. So differentiate both sides with respect to x. So here we have the product of two functions. So we have square root of 1 minus x square times derivative of dy over dx, which is d2y over dx2, and plus, then we have the second function dy over dx times the derivative of square root of 1 minus x square, which is equal to 1 over 2 times 1 minus x square times minus 2x, right? And this is equal to, because we are differentiating both sides, so we have m times dy over dx, right? Okay, now what we will do, now here we have 2 and 2 get cancelled, so we have square root of 1 minus x square, we have the second derivative, and then we have minus 2 and 2 get cancelled, so we have minus x divided by square root of 1 minus x square dy over dx minus m dy over dx equal to 0. Now we can substitute the value of dy by dx as this expression here. So we have a square root of 1 minus x square d2y over dx2, and we can write this as minus x divided by square root of 1 minus x square plus m times dy over dx equal to 0. Now if we divide both sides by square root of 1 minus x square, square root of 1 minus x square, then we have d2y over dx2. Then we have here x divided by 1 minus x, square root of 1 minus x square plus m. Then we have 1 over square root of 1 minus x square, and here we have dy over dx equal to 0, right? Now let us substitute the value of dy over dx as my over square root of 1 minus x square. So for simplicity I am denoting the second derivative as y2. So we have y2 minus x divided by square root of 1 minus x square plus m. This is 1 over square root of 1 minus x square times we have my over square root of 1 minus x square, that is equal to 0. Now y2 minus, we have x over square root of 1 minus x square plus m, and times my over 1 minus x square, because square root of 1 minus x square times square root of 1 minus x square is 1 minus x square equal to 0. So therefore y2 can be written as, if we take this term to this side, that is right hand side, then we have x over square root of 1 minus x square plus m times my divided by 1 minus x square, 1 minus x square. So this is the second derivative of this function.